let's look at this question. Now we have A1, A2, A3 as three distinct real numbers in geometric progression. And the given two equations have a common root. Then we need to find out which of the answer options are necessarily true. Now, let me consider certain values for A1, A2, A3 so that solving the question becomes easier. Now, three numbers in geometric progression. So let me consider A1, A2, A3 as 1, 2, and 4. Right? Now, substituting these values in the first equation, the equation becomes x square plus 2 into 2x plus 4 equal to 0, or x square plus 4x plus 4 is equal to 0, which can be written of the form x plus 2 whole square is equal to 0. Thereby, I get that this is a quadratic equation which has one root repeated twice, which is minus 2. Now, if the given two equations have a common root, and since the first equation has only one root, it means this one has to be the common root for both equations. So substituting x is equal to minus 2 in the second equation, we get b1 into minus 2 whole square plus 2 into b2 into minus 2 plus b3 is equal to 0. Now, I will be able to write it as 4b1 plus b3 is equal to 4b2. When you see the answer options, all of them are in terms of either b1, b2, b3 alone, or b1 by a1, b2 by a2, and b3 by a3. Now, when you see the given equation, 4b1 plus b3 is equal to 4b2, it is very clear that b1, b2, b3 are neither in arithmetic progression nor in geometric progression. So option A and option D are eliminated. Now, since both option B and C talk about b1 by a1, b2 by a2, b3 by a3, let me try to modify the equation that we have now in a similar format. So I can write this as, if I divide by 4 throughout, I get b1 plus b3 by 4 is equal to b2. Now, in order to be able to compare it with b1 by a1, b2 by a2, and b3 by a3, I will write this as b1 by 1 plus b3 by 4 is equal to 2 into b2 by 2. Now, if you observe, we know a1, a2, a3 are 1, 2, and 4. Thereby, this equation can finally be written as b1 by a1 plus b3 by a3 is equal to 2 into b1 by b2 by a2, which sort of makes us understand that b1 by a1, b2 by a2, and b3 by a3 are in arithmetic progression. Hence, answer option C. Question number 8. Now, this is one of those questions that seem to be difficult, but in actual, it's quite simple. Let us see what is the information we have in hand. There's a polynomial p of x, and when I divide this by x minus 1, the remainder is 2. And if I divide the same polynomial p of x by x minus 2, the remainder is 1. Meaning, if I substitute x equal to 1 in p of x, that is p of 1, the remainder must be 2. And if I substitute x is equal to 2 in P of x, that is P of 2 should leave a remainder of 1. Now let us see which answer option satisfies these two conditions. So substituting x equal to 1, I need to get a remainder of 2, and substituting x is equal to 2, I need to get a remainder of 1, which is satisfied only by option D. Hence, the remainder when P of x is divided by x minus 1 into x minus 2 will have to be 3 minus x. Let's look at this question number 9. Now we have A, B, C, real numbers greater than 1. N is a positive real number not equal to 1. And if log A base 2 base n is equal to 1, and so on and so forth, which of the following is true? Now these type of questions are better answered by substituting certain values for n and eliminate the answer options that do not satisfy, or identify the option that satisfies for different values of n. Suppose if I take, normally I would have taken n as 1, but in the question it's mentioned explicitly that n is a positive real number not equal to 1. So if I take n is equal to 2, then the first expression, log A base 2 is equal to 1. So by definition of logarithm, I can say log A base 2 is equal to 2. By applying the same definition, I get A is equal to 2 square, 4. Similarly, log of log B base 2 base n is equal to 2, which means log B base 2 is equal to 2 square, 4, and B is equal to 2 power 4, 60. The third one, log of log C base 2 base n is equal to 3, which gives log C base 2 to be equal to 2 cube, that is 8, and C is 2 power 8, which is 256. Now, let us substitute the values of n, a, b, c in the answer options and eliminate the ones that do not satisfy. Now, clearly, a plus b is not equal to c. Now, a power n plus b power n is equal to c power n. Now, clearly, 4 square plus 16 square is not equal to 256 square. Option C, b minus a whole power n, which means 16 minus 4 whole power 2, and c minus b, that is 256 minus 16. Now 16 minus 4 is 12. 12 square is 144, and 256 minus 16 is 240. Both are not equal. So the moment we eliminate 3 answer choices, obviously the remaining one will be the correct choice. But just to be on a safe side, you can verify whether the expression in the left out option holds true or not. Now a power n, which is 2 square, plus b, that is 16 whole square, is equal to a into c. Now a is equal to 4 into c is 256. Now if I apply a square root on both sides, I get 2 square plus 14, or 2 square plus 16. 4 square, I'm sorry, it's 4 square. So 16 plus 16 is 32, is equal to square root of 4 into 256. That is 2 into 16, which is equal to 32. Hence, with confidence, we can mark option D as the right answer.